Hey guys, this is Mrs. Lyons, and I'm going to try to do this again. I did this page once and my computer died, so let's hope that this time it doesn't die. All right, so where did I leave off? I believe I did everything but number 8 on the bottom of page 2, and then this video will go through page 3. And this is a lot of conversions, okay? And some of them look a little bit different than we've seen, but you will see kind of these two-factor conversions. There are one or two of them on the test, so don't get overwhelmed if it's a little confusing. All right, so if you look at number 8, it says we have a 140 milliliter tube of toothpaste, and it contains, what this means is 0.3% mass over volume. So basically what that's saying is that, and when it says mass over volume, it's talking grams over milliliters, okay? So this is kind of a common way that some of these things are done. So the formula is literally percent mass to volume is equal to mass over volume times 100. Okay, so we're just going to plug these things into this formula. All right, so if I have a 0.30% is going to be equal to the mass, which is what we're looking for, over 140 milliliters. Okay, so if I plug that into my calculator, which at this point I'm using my phone, 0.3%, okay, times 140 is equal to 0.42. So this tells me that my mass is 0.42 grams. Now, if I were doing this, I would go back and just make sure that that makes sense, okay? So for example, what I would do is I would plug my mass in, mass over volume times 100, and see if I get 0.3. Okay, so let's just do that. So 0.42 divided by 140 is that times 100. Check it out, 0.3. Okay, so that is how you would do a percent mass to volume question. There's another one, I think, on the next page. Okay, all right. So this next one is a medical question, but it's honestly just a conversion. Okay, so you got to look at these and not stress because it's a lot of information. You just got to figure out what of that information you need to use. Okay, so this says a doctor orders 1,500 milligrams of a medication for Mr. Cameron who weighs 185 pounds. The label on the medication states that the recommended dosage is 15 to 25 milligrams per kilogram of body weight. Okay, is the dose prescribed by the doctor safe for this patient? Okay, so basically we need to do two calculations. We've got to calculate the low end and the high end of this dose. Okay, so what I'm going to do is I am going to start with Mr. Cameron's weight. So 185 pounds. Okay, I'm going to put that over 1. First thing I'm going to do is I'm going to convert that to kilograms using the conversion that's given in the problem. So 1 pound is equal to 0.453 kilograms. Okay, the next thing that I'm going to do is I'm going to use the dosage. The dosage says that for every 1 kilogram of body weight, the low end dose would be 15 milligrams of the medication. Okay, so now if I look at this, my pounds cancel, my kilograms cancel. I'm going to end up with an answer in milligrams. So let's see, 185 times 0.453 times 15 is 1,257. 1,257 milligrams. So that would be the low dose for Mr. Cameron's weight. Now I'm going to calculate the exact same thing and figure out what the upper dosage would be. And then I can figure out if the dosage that the doctor prescribed is accurate. Okay, so I'm going to do the exact same calculation. And this time it'll be 25 milligrams. Okay, so I'm going to do 185 times 0.453 times 25. The upper dose is 2,095 milligrams. Okay, I'm not going to worry about sig figs here because the answer is just going to be, is this 1,500 milligram dose safe? So if the low dose is 1257, the high dose is 2095, that dose is safe. Okay, so that's what that is looking at. All right, a doctor writes an order for Tylenol, 160 milligrams by mouth as needed for a kid who's got pain. The pharmacy gives you a prescription of Tylenol for your little kid of 80 milligrams per milliliter. So the question is, how many milliliters do I have to give the child in order to ease their pain and not, poison them? So we're going to start with 160 milligrams. Okay, that's how much they need, okay, for their pain. And it says that a dose that they give you is 80 milligrams per milliliter. So you got to remember, when you see the word per, what that means is this is 80 milligrams per 1 milliliter. Okay, so my milligrams are going to cancel. I end up with milliliters as my unit. So 160 divided by 80. I didn't need to do my calculator to do that, but my answer is 2 milliliters. And if you look, 80 has only one sig fig, so our answer is only going to have one sig fig. All right. Here's another mass percent. Calculate the mass volume percent of a 762.5 milliliter solution that's prepared by dissolving 289.15 grams of calcium azide. Here's the cool thing about this. We don't need to worry about what the compound is. One of the things you've got to do on this test is kind of figure out which things you need to pay attention to and maybe which things you don't have to pay attention to. Okay, so if you remember, percent mass over volume is equal to mass over volume times 100. So 289.15 grams over 762.5 milliliters times 100. So 289.15 divided by 762.5 times 100. Our percent mass to volume is 37.92. 1, 2, 3, 4, 5. 4 sig figs. So I can do 37.92%. All right. This next one is a solution concentration. I don't know if we did any of these, but this is a pretty straightforward thing. We use the equation M1V1 is equal to M2V2, which means the molarity of the first solution times the volume of the solution is directly proportional to the molarity of the second solution times the volume of the second solution. The thing you've got to make sure of is that you have the same units, okay? And we kind of tripped you up here because we said 175 milliliters, and here we have liters, okay? So all we have to do is convert milliliters to liters, and we can figure out the concentration of M2, okay? The other thing you want to do is make sure that you connect the right numbers. So this is saying we have 175 milliliters of a 0.16 molar solution. So I'm going to do molarity 1.6 times volume 0.175 liters. Okay, we got to convert to liters, is equal to M2 times V2, or V2, which is 1 liter. Okay, So if I plug this into my calculator, I do 1.6 times 0.175 divided by 1 is going to be 0.28. All right, and that's big M for molarity. We could write that one of two ways: 0.28 big M, or we could do 0.28 moles per liter. Those are the same things. Okay. Sig figs. This number has 3, this one 2, this one 2. So 0.28 does have the right number of significant figures. All right, they'll have something this hard on the test. But here's what you have to think about. Okay, it says how many milliliters of 5 molar copper sulfate solution must be added to 160 milliliters of water. Okay, so what we've got to think about is M1 is 5.0 molar. Okay, that's the amount of solution. Okay, and we're adding some amount. So I'm going to say X. Okay, X is how much the volume of this solution is. Okay, so we're going to add some amount of this 5 molar solution to water. Okay, or we want a certain amount of this, and then we're going to add it to water to dilute it. Okay, so we want to have a 0.3 molar solution. Okay, the amount of this solution is going to be how much ever of the 5 molar solution we used plus 160 milliliters. So X plus 160 milliliters. Okay, so we got to do a little algebra here. So basically 5.0x is equal to 0.30x plus 0.3. I'm distributing that 0.3 through to the 160 milliliters. So plus 48 milliliters. Okay. So now we need to get our x's all on the same side. So 5x, I'm going to subtract 0.3x. Okay, does that make sense? 5 minus 0.3x is going to equal 48 milliliters. So 5 minus 0.3 is going to be 4.7 times x is equal to 48 milliliters. So now I'm going to take 48 divided by 4.7. All right, so the answer that I just got is 10.21 milliliters. Now we got to think about, what does that mean? What is that number? Okay, that number is how many milliliters of this 0.5 molar solution we would use. Okay, so basically I'm saying if I were to go back here and plug this into this formula, okay, I'm saying that if I have a 5 molar solution and I add I have a volume, if I have 10.21 milliliters of that solution, okay, I am going to make, and I'm just plugging this in to make sure this makes sense, okay, 0.3 is our second molarity, so 0.3 molar times, and let's just leave this as V2, and let's see what we get, okay, so I'm going to do 5 times 10.21 is equal to 51.05, and I'm going to divide that by 0.3. So that says that V2, okay, V2 is 170 milliliters. Now, does that make sense? Okay, so think about this. We're saying that, remember, we want to we want to make a 3 molar solution, and saying how much water do we add to this? Okay, so we have a 5 molar solution. We need 10.21 milliliters of that solution added to 160 milliliters of water, which will make 170 milliliters of our solution. Now, that was a tough question. Okay, I will double check the final and look and see if the question that you have to answer like that is that complicated or not, because that's a lot. So I will get back to you on that. But I did want to show you going through kind of that crazy the crazy calculation. Okay, so let's move on to the next one. I will get back to you on that question. All right. So question number 14. 5.10 grams of copper was heated from 20 to 80 degrees. How much energy was used to heat the copper? This is an easy one. Remember, Q is equal to M times C times delta T. All right. So this is asking us for energy, which is Q. So we're going to do Q is equal to 5.10 times C times delta T. So 80 minus 20 is 60. All right. So let's just calculate that. 5.1 times 0.92 times 60 is 281.52. So Q is 281.52. What are our units of energy? See, this specific heat is in calories, so our energy is going to be in calories. Okay, now I think I've got way too many sig figs. Let's look. 2 sig figs is all I can have, so Q is going to be 280 calories. All right. One more, and this again is another Q equals MC delta T. All right. If a 3.1 gram ring is heated using 10 calories and its temperature rises 17.9 degrees, calculate the specific heat. Okay, so our mass is 3.1 grams. Q, it's telling us that we use 10 calories. All right, it's telling us the delta T. Delta T is 17.9 degrees Celsius. And then we need to calculate C. Okay, so Q 10.0 is equal to 3.1 times C times 17.9. So let's plug this into the calculator. 3.1 times 17.9 is 55.49. So 10 is equal to 55.49 times C. All right. So 10, we're going to do 10 divided by 55.49, and we're going to get 0.18, so C is equal to 0.1802. How many sig figs? I can use 2 sig figs. So C is equal to 0.18. That's going to be calories per gram degree Celsius. Okay. And I was writing off the edge of the page. So there's page 2. That was a lot. Luckily, there are some easy questions on the test that go along with some of these brain teasers. All right. So I'm going to stop there for page 2, and I will see you in class